Assalamualaikum warahmatullahi wabarakatuh. We are from group 3. We are here to present about blender machine. We will meet our team member, which is Nur Atira Nadia binti Muhammad Faisal, Nur Aziani binti Amri, Yon Izmelisa Adaha binti Yon Ismail, and me, Nur Syahidah binti Zulkifli. For the intro, design for manufacturing and assembly, which is Dfma, is a systematic method for analyzing designs by organizing data in tables. It focuses on cost and time reduction in product manufacturing and assembly. So, this project aims to streamline product offerings by reducing the number of available products and associated costs. The focus is on blender machine, which is a home appliance, and utilizing the Dfma to minimize part count. So, the Dfma helps in rationalizing manufacturing processes and material selection, determining production costs, and enhance cost effectiveness and reduce development and manufacturing expense for product development and assembly, and contribute to lean manufacturing practice. So the Dfma serves as a reference tool for competitor analysis and cost analysis during supplier negotiation. So we go to the problem statement for this project, which is the team assess assembly efficiency using a blender machine. Considering ease of handling and installation, despite software and availability, a plan was formulated to implement the Dfma, aiming to reduce costs, improve quality, and enhance performance. And number 2, which is the objective, to reduce the number of parts of the product and redesign the desired parts to reduce cost and time. Number 2, to evaluate original installation efficiency and product redesign using the manual Dfa evaluation sheet. And number 3, to compare the installation efficiency of original and redesigned products in terms of assembly time and assembly cost. So the scope included the product parts will be disassembled and evaluate to study its function. The product design will be improved and the cost will be calculated manually by using the Dfa table. And both original design and improved design will be compared based on the Dfa table.
Okay, now I will proceed for methodology. So here is methodology of the project. So we're starting with introduction, and then we proceed with problem statement, objective, and also the literature review. The next step is overview on existing part dimension, and then we make a DFMA analysis. We proceed to modify and reduce part for each assembly, and then we make a DFA analysis for modified part, and then we get the result, and also we make a conclusion. Next, also in the methodology, we have step in manual DFMA. So basically, there are 6 steps in manual DFMA. The first step is define the product and scope. We define the product under analysis and specify the intended production volume and target cost. The second step is disassemble the product. During the assembly process, documenting each component along its respective material and function, and generate a visual representation of the assembly sequence. The third step is part identification, encompasses detailing the name of each part, its dimension, the manufacturing process employed, and also the material utilized, and systematic recorded in a table format. The fourth step is design for manufacturability DFM analysis, evaluating component complexity, focusing on the simplification and the standardization. Assess the suitability of the chosen material concerning cost, manufacturability, and the performance. The fifth step is design for assembly DFA analysis. Assesses the ease of handling and assembly component of each assembly step. Explore the flexibility of incorporating standardized fastener and assembly technique for improved efficiency. The last step, which is the sixth step, is the FF table. Gain insight into determining the estimate time for manual handling and insertion, employing of a total 12 identified method. For project flow, there are 6 steps, which is the first one is introduction. In introduction, objective defining and understanding the FA methodology. The second step is project planning, concept generation reviewing existing blender and establishing blender selection. The third one is literature review, gathering related information, catalogs, and the latest product design. For the fourth step, which is methodology, the assemble of blender part and dimension each measurement of each part. The second last step is Dfma analysis, evaluating each part handling and section coding and design efficiency calculation. And the last part is redesign, defining potential part to modify and second evaluation and result comparing. Now we're still in methodology. The second last point in the methodology is report and documentation. The project is systematically executed by adhering to standard operations procedure, which is SOP. Each step is meticulously undertaken with method and collecting data being documented to ensure that the redesigned product supports the functionality of the previous design. The last point in methodology, which is summary. Achieving a well-executed redesign is possible through a comprehensive examination of the method and adherence to the procedural steps. This sector demonstrates the fusion of the theoretical analysis related to the specified method and principle associated with the domain of DFM and DFA.
So we go to the part identification. We have 17 part identification, which is housing mainframe, blade nut, blade, button and circuit holder, jar lid, housing base, housing lower cover, housing outer cover, jar, lower blade joint, measuring cup, rubber foot large, rubber foot small, seal ring, upper blade joint and motor.
So basically here is the DFA analysis for original design. So basically we construct a DFA table for original design in order to get the total manual assembly time, total manual assembly cost and also minimum number of parts. So basically in the DFA table there are consist part ID, operation, handling code, handling time, insertion code, insertion on time, operation on time, operation on cost and also minimum number of parts. So after uh, we do the analysis of every part and then we get the total of TM, CM or NM. So with these three value, we can get the design efficiency of the original design.
Okay, so we go to the sketch comparison between original and improved design. For original, we have 17 parts, and for improved design, we have 11 parts.
Now we proceed for the improvement suggestion. So basically there are 5 improvements that we do it into this blender machine. The first one, we combine the blade frame and the seal ring into a single part. The second is combine blade nut, upper blade joint and the lower blade joint into the one part. The third is combine housing mainframe, button and the circuit holder, rubber foot large and rubber foot small into the base part. The fourth one is change the material of the jar from the plastic to the stainless steel. And the last improvement is change the material of the housing mainframe, housing base, housing lower cover and housing outer cover from aluminium to stainless steel. So here is the DFA analysis for improved design. So basically we do the analysis for the improved design in order to get the design efficiency. Now I will proceed for the last part in result and analysis, which is the performance comparison between original and improved design. So in terms of the design efficiency, we can see the design efficiency for original design is 66.81%. For improved design is 72.87%. We can see the differences between the design efficiency between original and improved design is 6.06%. In terms of number of part, we can see that the original design we have a 19 part, and for the improvement after we do the improvement, we get only 11 part. So the difference is 8 part that we already reduced. For operation time, the original operation time is 85.3232 and for improved design is 45.28. The differences between the improved and original operation time is 40.04. For the operation cost, the original operation cost is 34.12 and the operation cost for the improved design is 90.69. So we can see the differences between the operation cost of original design and also improvement design, which is 14.43. So from this comparison, we can see that the improvement design, which is the improvement blender machine, we can see that we get to improve the design efficiency. We increasing the design efficiency. We reducing the number of parts. We reduce the operation time. Also reduce the operation cost. So the improved design is better than the original design.
I will be presenting for the discussion of the report. First, combine the blade frame and seal ring into a single part. Okay, first, the blade frame is a structural support for the blender blades, ensuring they remain securely in place. Meanwhile, seal ring form a tight seal between the blade assembly and blending jar, and also it prevent leakage during blending. And lastly, the benefits of combining the blade frame and the seal ring into a single part is operator deal with one component instead of multiple. Also, it reducing risk of errors and speeding up assembly time. Okay, for the discussion for the second one is combining the blade nut, upper blade joint and lower blade joint into one part. Okay, as we all know, blade nut is a threaded component that screws onto the blender's motor. It prevents blades from becoming loose. Okay, meanwhile, the upper blade joint function as to connect the blender motor shaft to the blade assembly, ensures that blade spin effectively. And lastly, for lower blade joint is used to provide support and alignment for the blender blades. Ensure that the blade are properly positioned. Okay, the benefit from combining those three things, those three components, as they work together seamlessly to securely hold the blades in place, transmit rotational motion from the motor shaft to the blade, and ensure the proper alignment and support effective blending. For the discussion for the third one is combine housing mainframe, button and circuit holder, rubber foot large and rubber foot small into the base part. Okay, so first is design optimization. By combining them into one part, simplifies the overall design of the blender. It also reduces number of parts and eliminate unnecessary component. Okay, the second one is cost saving. Fewer parts mean reduced material usage, lower assembly time and decreased labor costs. Okay, the third one is enhanced efficiency. By combining them, manufacturing becomes more efficient. Also, it leads to improve overall efficiency in assembly process. And lastly, for the streamlined assembly, integrating button and circuit holder into the base part eliminates the need for additional fastener or assembly steps.
Next discussion, change the material of the jar from plastic to stainless steel. We choose stainless steel because highly durable and resistant to damage. This ensures a longer lifespan for the blender, reducing the need for frequent replacement. Next, non-porous and less prone to contain bacteria or smell. It makes kitchen hygiene better because it's simple to clean and sanitize. Third, can withstand higher temperature. Stainless steel allowing for hot liquid to be blended without the risk of warping or melting. Fourth, eliminate concern about chemical leaching into food. Some plastic that may contain harmful chemical like BPA. And lastly is more environmentally friendly, since it is recyclable and has a longer lifespan. 4. Change the material of the housing mainframe, housing base, housing lower cover, and housing outer cover from aluminium to stainless steel. We choose stainless steel because it's more durable and stain, corrosion and dent resistant. It ensures that the housing component remain intact and maintain their structural integrity over time, reducing the likelihood of damage and extending the lifespan of the blender. Next is more stable and sturdy than aluminium. It helps prevent wobbling, vibration or deformation for the housing component during operation, ensuring smooth and consistent performance. Third, offers superior heat resistance compared to aluminium. It is suitable for blending hot ingredients without the risk of warping or deformation. And lastly is stainless steel is recyclable and has a longer lifespan. It can reduce the environmental impact associated with the production and disposal of blender component.
Okay, so in conclusion, the blender's design improvement driven by reduced component count, simplify complexity, enhance efficiency, lower manufacturing costs, and evaluate product quality. The Dfma analysis guides the transformation, emphasizing simplification and functional adjustment. Part reduction optimize production, yielding a more sustainable and efficient product. The Dfma principle provide critical insight into production impacts, balancing utility, affordability, and production viability. Ultimately, reduce part count and material changes significantly boost design efficiency and reduce assembly costs.
For the recommendation, the blender machine require enhancement in power efficiency, noise reduction, and blade design. These include powerful motors, noise reduction technology, innovative blade design, safety features, compact design, easy cleaning, and smart connectivity for improved user experience. I think that's all from us. Thank you.